Okay, today we're going to look at a third type of situation where we could be required to change a base. Okay. Now this question here is worded a little bit differently. It's asking us for what values of x will this statement be true. It's actually the same as solving. If we're being asked to solve, we're just being asked to find x, so we're actually just doing the same thing here. Okay. Difference being with this question is we still have a base and an exponent on the right-hand side, but on the left-hand side, we have a base and exponent, but that's also being multiplied by something else. Okay, so the aim here is still the same. We need all three of these terms to have the same base. We've got two the same this time, so we're going to change this 8 so that it is base 2. Okay. Going back to our facts, 8 is 2 to the power of what? 8 is 2 to the power of 3. So we're going to come in and just replace that 8. It's the only thing that we've changed. Replace that 8 with 2 cubed. Okay. So now everything has the same base. So essentially we can remove those bases and solve it, just like we did before. However, we need to think carefully about how we're going to simplify this left-hand side. So I'm going to take you back to just a quick recap for the moment to do with rules of exponents. I want to make a little note of this. So if, let's say, I had 2 to the power of 3 and I multiplied that by 2 to the power of 5, and I wanted to ask you to simplify it, 2 to the power of a single number. Okay. So if we think, right, on my left-hand side I have 2 cubed, which is 2 times itself 3 times. And on the other side, I have 2 to the power of 5 times itself 5 times. So altogether, I'd have 2 to the power of 3 plus 5. And that's that rule of exponent where we add those exponents. So you would end up with 2 to the power of 8. Okay. Therefore, we need to use that same rule of exponents to simplify what we have here on the left-hand side. Okay. We have 2 cubed plus 2 to the power of x. Imagine that x was this 5. We would do 3 plus 5, but we don't know what that is, so we're just going to have to simplify it to 3 plus x this time. Okay, and that's where that rule of exponents comes into what we're doing here. Now we have an equal base, and we only have one term on the left and right. We've combined those two. So because we now have that equal base that we're looking for, we can remove the bases. And therefore, those exponents must be equal to each other. And we can solve in a linear fashion like we did before. So this is my lowest x. So I'm going to take that away from both sides. Okay. Then remove 1 from both sides. For x equals 1. To finish that off. 2 divided by 2 gives us 1. Okay, so that's the final example, and I'd like you to give a few of these a go now. So you can flick back and forth to this example. The 5 questions that I've got for you are listed there, so you can pause the video now and go back to the example or leave it on these if you wish, and then you can come back for the answers once you are done. Okay, answers. These should be your answers for those 5 questions there. Question 5 was a little bit different. So if you had a go at that one, that's a little bit extended beyond what I've covered today. So don't panic too much if you didn't know what to do there. But you can have a little look at question 5 there and see if you can work that through. Okay. Otherwise, that's us done for solving equations changing the base. And I'll talk a little bit about it in our next Zoom. See you then.